Now that we have talked about all the characteristics of metals and non-metals, let's move on and see how do these metals and non-metals react when they are subject to different conditions and certain substances. Now let's talk about metals reacting when they are burned in air. Now, whenever you burn a metal in air, you have a clear reaction of oxidation. Now, oxidation is nothing but the addition of oxygen, so hence you can expect the formation of a metal oxide. So when you burn copper, for example, with oxygen, you get copper oxide. Now, all these burning reactions of any metal have a certain characteristic. Now, suppose you're burning magnesium in open air. Whenever you burn magnesium, you can see that there is a characteristic color of the flame, which is a white dazzling flame. Then when you burn rubidium, what you get is a dark red flame. Or when you burn cesium, you can get a blue flame. Similarly, copper also gives out a light bluish turquoisey colored flame. Now, these flames are used to understand which element is present in your sample. From previous chapters, you might have understood that the metal oxides are usually basic in nature, but there are some metal oxide like aluminium oxide which can act both basic and acidic in nature, and hence they can react with both bases and acids. Bases meaning alkalis and acids. Now, suppose you're reacting aluminium oxide with dilute hydrochloric acid. What you get is aluminium chloride and hydrogen gas. And what if you're reacting it with sodium hydroxide? So you have aluminium oxide plus sodium hydroxide giving sodium aluminate and water. Now, if you've noticed and if you remember that these bases are usually not soluble in water, but there are some bases or these metal oxides which are soluble in water, and hence they are called as alkalis. Now, remember one thing. Whenever you are trying to check the solubility of any metal oxide or any metal in water, one thing you need to remember is check its reactivity first. Because there are elements or metals like sodium and potassium which are at the top of the reactivity series and react very violently with water. And there are some like copper, whenever you try to burn them, it does not actually burn, but it has a coating of a black layer and you have the formation of copper oxide. Now, if you do remember, we have studied the concept of corrosion to which every metal is susceptible. Now, if you look around yourself, you can find that there is metal in different forms. It may be automobiles or aircrafts or locomotives. Now, you do not always see that an automobile or a locomotive or an aircraft is rusting or is corroded. The reason is simple. For any automobile to be safe from corrosion, the manufacturers subjected to a treatment called as anodizing, or they dip it in an anti-rust solution. Now, let's talk about anodizing. Anodizing is a process wherein you have the formation of a thick layer of oxide over aluminium. Now, this thick layer of aluminium protects the aluminium from being rusted. The thicker the layer, the more protection does the aluminium have. Now, this is most important for large ships and aircrafts, as they are in a place where there's a lot of moisture for aircrafts and a lot of water for ships. Now, this is also one of the same reasons why aluminium is a preferred material for the chassis of the car.